Hi, this is the YouTube channel for Math Contest Go Go Go. What I want to do for this channel is to build a platform for math lovers in order to make them discuss about different kinds of math problems. I will update a video about challenging problems every day. If you would like, please subscribe below. Now, let's begin. Today, let's discuss another computing problem that is very related to the math, which is called exactly electrical. It's like you live in a city which is composed of integer number streets which run east-west and east number avenues which run north-south. So this means the problem means that there's a city that is run by grids. What you need to do is assume I give you 2 points. One's A and one's B. And if you go past one grid, one unit, you will lose 1 electrical power. The problem is ask you to find whether you can reach the destination, which is B, when your energy is exactly over, which means when you reach B, it reaches exactly 0. So, talking about the most important thing, input specification and output specification. Input. It consists of four numbers. The first 2 is A, B, which represent the starting point, which is A. The second one is C, D, which represents the ending point, which is B. Yes. So the fact is, and the E means the energy you have. So A and B has a range of this, while C and D also have the range same as A and B. The third line contains integer T, which represents the total energy you have. It has a range of this. And there is some exceptions. So for 3 out of 15 available bugs, A, B, C, D is larger than 0 and less than 2. Another 3 points T is less than 8. So if you can't think about any ideas, you can just hard code every way. Like if A is 0, B is 0, C is 1 and D is 1, what is the result? It's another. In fact, to do this problem, you are able to use DFS and BFS. But I can say it will be very hard and it's not worth it to use DFS and BFS. So there's a way of getting it easily. We can draw a line which consists of 3 times 3 grid. Is this 3 times 3? Oh, it's 4 times 4 grid. We assume this is starting point A. If we want to reach here, we will spend 2. D. The shortest way of achieving a road is like C minus A plus D minus B is equals to F, which is the shortest length you can go. So first we can make sure if the energy is less than the shortest length, then it's definitely you just enter out force. If E is equals to shortest length, then you definitely do it's true. So the thing we need to discuss about is what if F is larger than E? So we can draw a grid to show a way that can do this problem easier. So it's a 4 times 4 grid, which we set the starting point as A and ending point as B. The shortest length is 1 plus 1 equals to 2. Like if we set the possible as 3, let's show how it's not possible when energy is equals to 3. You can see if we try to make the root higher, I mean by going up or going right. We can try going up. This will be here, so there will be 2 more. If we continue going up, so if we continue going up, then this will be this, and we still need 2 more. So what we can find on these circumstances is like, for every grid we add, there will be 3 lines adding. However, there's 1 line that we don't need to use anymore. When we add. So how does this mean? Like, for example, if we want to make this route, this is 2 to this. The shortest route is here, 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 here. While the center is still B. And we are expected to also include this. But this does not exist. I mean, we don't need to work on this anymore if we want to achieve to go there. So which means that every grid we add will cause 2 energy increasing. So this means that if we have an odd number of lengths, shortest lengths, then every type of possible length is odd. If we have a type of even length, then even shortest length, then every type of length will be even. So we transfer this into the problem, which means if electrical has odd, is odd, and root shortest is even. Then we just definitely print out false. On the opposite side, it's also the same. If electrical has even and the root is odd, it's also false. So now we have analyzed every type of outcome it can be, and we can see the code. On this platform, we are going to show how this code works. First part is easy. I don't need to explain. Print out 5 numbers, then close the scan. And this one is the shortest length called F. We just, if E is equal to F, which means the energy is equal to the shortest length, it's yes. Else, if E is larger than F, we divide it into 2 parts. If F minus E divides 2 has a remainder of 0, which means that F and E are both odd numbers, or F and E are both even numbers. Let's repeat. F and E are both odd numbers, or F and E are both even numbers. This will lead to the result of yes. Else, we just print out no. The last possibility is E is less than F, which means energy is less than the smallest root to get to the, energy is less than the smallest length that requires to go there. We'll just print out no directly. In fact, problems, they have many solutions, and my solution is only a part of them. If you have more challenging solutions, please comment below. And don't forget, I will also post my problems there. See you tomorrow!